All right, so looking at 6.1b, we're now trying to figure out what the angles are in the unit circle. So I've got up my unit circle cheat sheet, if you will, where I have all the angles already marked and what their positions are as far as XY coordinates. So in 45, they ask us to go here. And they tell us at this point, if you look at it closely, that point is, I don't know exactly what that point is, but I can tell that it's the same for X and Y. So if it's the same for X and Y, this must be pi over 4, because that's the only place on my unit circle where I have X and Y are the same. And you can tell that when you look in the book. Here's my book and their actual example. You can look on the grid and see, okay, this is like 0.7 something, and the same thing for the Y value. For 46, they want us to go from 0 down. That means I know that my angle will be a negative angle because of the direction. I'm going south first. And to get here, I look at the coordinate points for that, and I've got the Y value is negative 0.5. So I look for here on Y values that are negative 0.5, and this is going to be 7 pi over 6. So 7 pi over 6. For 47, we're going up, and we're going all the way around to this one. This is not in the middle. This is not a pi over 4 position. It's either going to be a pi over 6 or a pi over 3. And this one I know is a pi over 3 because I'm really good with my unit circle. But here's how you can count it out. So the ones furthest away from the x-axis are the pi over 3s. So this is 1 pi over 3, 2 pi over 3, 3 pi over 3, and this one's 4 pi over 3. So for 47, we're going all the way around to 4 pi over 3. And it's positive because we started going up. 48, we've got to go around in a circle. So 48 says go down, so negative, and here's one complete revolution, and then come all the way back around to here. So we're ending at pi over 2, but we went all the way around once. So the once all the way around this part is 2 pi, and we went in the negative direction, so we went negative 2 pi backwards around the circle, and then we're going to go another pi over 2, pi over 2. This is another in the negative direction, 3 pi over 2. So I'm actually going to add those together, and I've got both of them with the correct sign because I went around and around again, and that's going to be, if I make them both common denominators, 4 minus 3, negative 7 pi over 2. Now, does that make sense? So consider if we'd have gone all the way around here, we would have gone to 4 pi. So we're 1/2 pi short of 8 pi over 2, which would have been 4 pi, because 2 complete revolutions would have been 4 pi, and in the negative direction, so negative 4 pi. So negative 7 pi over 2. I did my 1 revolution, that's 1, and then the other one was 3/4 of the complete circle, but it's 3 pi over 2. I've got a half, and another half, that's 3 halves. All right, 49. 49 goes up, once around, and then down to, where are they going here? This one goes completely to the middle, and you can see that because it goes to the negative 1, 1. So I have the same position like I did in this example. This is a pi over 4. Which pi over 4 is this? So let's see. This is up, and once around, this part is 2 pi. Then we kept going, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 is pi, so that makes sense. And then this is 5 pi over 4. Then we add those together, so we have 2 pi is the same thing as 4 pi over, oh, we need it over 4. Silly me. 8 pi over 4 plus 5 pi over 4 is going to be 13 pi over 4. So hopefully talking through this, that's making a little bit more sense if you were confused before. 50, I'm going in the positive direction. I've already drawn the radius in there where I'm stopping. And this value here is a half. So if you go and look at your unit circle over here, the one that has x, so horizontal distance is x, is a half. And so that's going to be the 2 pi over 3. So this is 1 pi over 3. This is 2 pi over 3. I'll just write it down here. 2 pi over 3 for number 50. So drawing those is really important, and being able to think about whether you're going up or down, how many times you go around the circle. 57 asks for arc length. Arc length is represented with S because we talk about the length of the arc subtended. So we're talking about, in this example, if we went here, this and this represent this angle, and we're talking about walking on this distance. So the arc length is radius times the angle measure. We're saying that the radius is 4 inches, so my circle is this big, and I have an angle measure of 1. So that's going to be hard for us to know what that means because this is in radians. But we can figure that out when we think about what it means to be pi. So if you think about this being 0 and this being 3.14, then if we divide this about into thirds, right, then this is about an angle of 1. So normally on the unit circle, we think about it as split up, divided, so pi divided. But this is actually the same thing as 0 to 3.14. That means that 1 is somewhere here, and then 2 would be somewhere over here, and this is 3.14 exactly. So 3 is a little bit less than here. Anyway, all I have to do for 57 is say 4 times 1 equals 4 inches. For 57. For 58, they asked us to round. So for 58, the given information is the radius equals 9 centimeters. The angle is pi over 2. And so they asked us to say S equals 9 times pi over 2, or 9 pi over 2. And then they actually want us to tell it in hundredths. So we're going to say, I've got a lot, there we go. 9 times pi equals divided by 2. So we're going to say 14.14 centimeters. 59, 11.78 feet. 60, they went and they threw us a loop. This has to be in radians for us to be able to use this equation. So we need to take 180 and make it into pi. And now we have the arc length is 80 pi, and then just plug that into a calculator. So you get, for 60, 251.33. 251.33. And that was in kilometers. So make sure that you take all the degrees and put them into radians in order to use the arc length equation. All right, a couple more answers out there to check. And then for 63, they just give you the same problem in words. So they gave us the radius is 5 inches, the angle is 17 degrees. I need to put that in radians, and they tell us, hey, please do that. They gave you a hint. So I'm going to multiply that by pi over 180. I'm trying to cancel the degrees, so I put 180 in the bottom. So then I can just put this in the calculator, 5 times 17 pi over 180, and that will give me the angle measure. I mean the distance on the arc. So 63 and 64, change this one to radians. 1.48 inches. 64 is already in radians, and so we just multiply the radius times the angle to 12.06 centimeters. 65, they gave us diameter 6 feet and the angle 68 degrees. So we need radius times theta in radians. So first I need to find the radius. So I'm going to say this is 3 for the radius. And then I'm going to say this is 68 times pi over 180. This will change this into radians, and I can just do that in one smooth maneuver because I've got my calculator to do the math. So then I can just type in 3 times 68 times pi divided by 180. And do use pi on your calculator. Do not try to put in 3.14. You're going to be off in your calculations when we're trying to round to the nearest hundredth. So you need the complete pi written out of there for your problem. So when we round this, we get 3.56, and we're still in feet. 3.56 feet. For 67, there seems to be a whole lot of extra stuff in this problem, but basically we've got a radius of the Earth of 6,370. We have an angle measure of 34 degrees minus 29.25 degrees. So we're saying that those two cities lie on the same longitude, which means that we can cut the Earth into some circle and they're on the same circle. But one of them's at 29 and one of them's at 34. And so we have to subtract them to find the angle measure. And then we're going to still multiply by 6370. So 6370, if I subtract these two guys, I get 4.75, 34 minus 29.25 times, so I need to say 4.75 times pi over 180. That converts it into radians. So I'm actually going to say 6370 times this. So I've got 4.75 pi divided by 180. That's the radians. And then I'm multiplying by 6370. So they're about 528.09 kilometers away from each other. So S equals 528.09 kilometers is the distance between the cities. Okay, so it looks like a really complicated problem, but you're basically finding the angle measure and the radius and using arc length. 72, same problem. They give me the angle difference between the two cities, so I'm going to subtract 51.48, 39.47. I'm going to multiply that by pi, and then divide by 180 to make it in radians, and that's my angle measure. So 0.2096140 times 6370, and that's the arc length. Arc length equals, so radius times angle measure in radians, and we get 1,335 miles away from each other. Okay, so really kilometers away from each other. Sorry about that. Okay, for 82, they tell us the Earth takes roughly 23 hours, 56 minutes to rotate once around its axis. So we're imagining there's this person standing on the equator, because they tell us that, and the Earth is rotating around its axis, and we're looking at them standing on the Earth going around in a circle. So they're going to go all the way around the circle because they say it takes to rotate once, so they mean one rotation, so that's going this way. That would be 2 pi. So they're 2 pi times the radius of the Earth, 3960. That's the arc length that they traveled, and that's the same as the problems we just did up here where we said S equals the radius times theta. I have them switched. I have theta here and radius there. So this is the total length they traveled over how long it takes them over time. So we're looking at, let me rewrite this as the linear speed is equal to the distance they traveled over time. And the distance they traveled is s, or r theta, and then we put time. So there's my tiny little equation there, r theta over time. Distance over time, that's what speed is, right? So I've got the distance they traveled as 2 pi, one revolution around the circle, which is the Earth, times the radius of the Earth in miles. And then they said it took 56 minutes, 23 hours, 56 minutes, and I need to make that into one number. So what is that in one number? That is 23 whole hours plus 56 over 60 for that part of an hour. So I'm going to put that here in the bottom, 23 plus 56 over 60. This is a portion of an hour. So when I put this in my calculator, I'm going to say I've got something that you need to see. There we go. Okay, so we've got 2 pi times 3960 miles. That's the numerator. 24881.41382 divided by, and then I'm going to say 23 plus 56 divided by 60 divided by 23.93333. Lots of threes repeating. So I'm going to go up and take the numerator and then divide it by the denominator, and we get 1039.61 miles per hour. There we go. That's how fast you're traveling. If you're on the equator in a day, you're traveling 1039.61 miles per hour. That's pretty cool. For number 85, this is the picture that they give me, and they want me to find the shaded portion of the area. So area of the total circle would be pi r squared. And I've got some portion of that. So I've got pi, in this case, r is 1, so 1 squared, times the portion of the circle that I have. So I have, they say that this point is at negative 0.5, nope, the 0.5 is the y. So this is got to be negative the square root of 3 over 2 and positive 1/2. If you look at their picture, it goes up 1/2. So this, if you look at your unit circle, is right here. So this is 5 pi over 6 is the angle. This angle is 5 pi over 6. And so we're going to say this is the total circle times the percentage of the circle. So just like I had to make this into a fraction, I have to say this is out of 2 pi. So this is a percentage of the entire circle. So when I simplify this, I'm going to have pi times 5 pi over 6 times 2 pi. My pi's will cancel. That makes it a little bit simpler. And then I can say that's equal to 5 pi over 6 times 2 over 1, or 1/2. That's 5 pi over 12. So I'll have 5 times pi divided by 12. So if you can read that, it says 1.31, and 85, I don't have any measurements. So there we go. So 5 pi over 12 is the complete answer with all of my decimals, and this is my rounded answer. So if you look in your book, it has the approximate equals there. And then our last problem, again, the book simplifies this equation, and I don't, because I'm full. Like, I don't know that I can memorize any more formulas. So I consider it to be total area times percentage of the circle. So pi r squared times whatever the angle is divided by 2 pi, because circles are always 2 pi around as far as the angle measure. So that's how I do it, and then I still got 314.16 feet because it was 100 pi when it simplified. Okay, so that does it for going over these problems from 6.1b. We figured out arc length and speed and area of a part of a circle using our trig and our unit circle. All right, see you next time.